Welcome back to the video series on test components. I am Stephen Duffy, Senior Systems Engineer here at Keysight. In this video, we will dive into Application Simulator. Let's first create a blank template to start. Now click on the pen and paper. So the first step is to look at what type of traffic do you want to run. Click on the ellipsis right here. Input the application profile that you want to run. Now, if you're not sure if it runs the proper traffic, click on the pen and paper. Each time you leave the configuration page, it will ask to save. This page will show the traffic mixture as well as how it's weighted. The weight can be based off of bandwidth or flows. The next part is data rates. If the data rate unlimited is checked, this means no limitation based off of throughput will be administered. Now, if you want to put a limit of throughput, uncheck the box. The data scope allows you to decide if the data limit is for the whole test or if it applies to each interface. The rate unit lets you choose from megabits per second or frames per second. The data rate type configures the fluctuation rate of your data. If you choose constant, then its only limiter is going to be the max, which is the number that you will see right here. Now, if you want fluctuation of the data limiter, you're either going to choose range or random. The difference of those is that random will choose a different rate between the min and the max every 1/10 of a second. Now comes the fun part. You just learned how to limit the test with data limits. Now learn how to limit with your flows. First, let's briefly discuss the differences of flows versus superflows. A flow is a single protocol connection using TCP or UDP. An example of this is whenever you set up a basic HTTP GET, this is considered one single flow. A superflow, on the other hand, is a version of an application which could have multiple protocols. An example of this is whenever you run a YouTube superflow, it is not a single HTTP flow, but instead it consists of 7 different HTTP flows and a DNS flow. Maximum simultaneous superflows indicate the concurrent number of superflows. So, if you create a superflow with one HTTP flow in it and set this to 100,000, then both BreakingPoint and your device under test will identify 100,000 concurrent connections. But here's the trick. If you create a superflow that is simulating an application and it has 3 HTTP flows and 1 DNS flow, then BreakingPoint will identify it as 100,000 still, but your device under test could potentially view it as 400,000 connections due to the different number of flows. Now, if you're running into this issue, a quick fix is to set up your maximum simultaneous active flows. This will limit the number of flows instead of superflows. So now if you run that same superflow with 3 HTTP and 1 DNS flow, BreakingPoint will show you running approximately 25,000 superflows, and your DUT will be showing you at 100,000 flows. The difference is BreakingPoint is still focused on the number of superflows, and your DUT is just focused on the number of flows. Maximum superflows per second. This allows you to limit the rate at which BreakingPoint will generate new flows. Now, the unlimited open rate box is used whenever you're not concerned about the flow rate. Now, if you want to create a scenario with closing flows and regenerating new flows as soon as possible, then you will want to check the unlimited superflow close rate, which by default is turned on. These configuration items that we just have reviewed will make the biggest impact on your test. Now, there are other options to configure it as well, to include DNS, source ports, TCP configurations. You can review these on your own, and if you have any questions, you can actually come up to this green question mark, click on it, and it will give you a description of what the option can do. Now we are going to discuss briefly how to configure your load profile. As you know, the load profile is a ramp up, steady state, and ramp down. So if you click on load profile, there's a pre-built configuration for you already. The easiest way is just to modify your ramp up time, your steady state time, and your ramp down. But a few other options you have here is during your ramp up, what type of TCP state do you want your connections to be in? Full open means a full TCP handshake. Then in your steady state, you can decide after your connections are completed with its data transmission, how do you want them to close or stay open? And lastly, on ramp down behavior, How do you want the current TCP connections that are open at the end of the test to close? Now we have completed a full application simulator configuration. If you want to save this as a template, just go up here to Save as Template, put a name in it. Now let's go back to the first page and see where to find your templates. Just select, Use Template, and here it is right here. If you're interested in additional information, please reach out to jointhejourney@keysight.com.